Hey, and welcome, and I appreciate you guys will actually rock up in the morning sessions. I know they're always my least favourite, like you always rock up tired and you're needing coffee and that sort of stuff. So hopefully mine's not too bad. So since there's quite a few of you I don't know, I'm Darcy, and for a bit of context, I've spent probably the last 3 or 4 years, almost all of my time, working with consuming and building and basically all the things that APIs do well and do horribly, learning them out the hard way. And so if you have any questions after the talk, I encourage you to email me or get in contact on Twitter or whatever, and we'll have 10 minutes at the end of the talk for questions. So when I'm talking about building APIs that developers love, I'm specifically talking about HTTP. I just want to clear that up at the start. So we're not talking about C APIs or anything like that. We're talking about APIs that operate over the web. And the first thing then that you've kind of got to consider is, well, why exactly is that important? And there's a bunch of different reasons, but the key one here is that it's increasingly becoming a defining interface to services. Things like Amazon S3 for storage, Twitter for communication, there's all these big services that they, for different reasons you may not be able to do locally, which we'll talk about a bit later, that they're using the web as kind of like their communication medium of choice. And so building for that and using those APIs are increasingly becoming an important idea. As a bonus, when you're using HTTP, there's a bunch of really, really good things you get. There's a huge variety of tools. So for instance, using the S3 API as an example, building something that's compatible with the S3 API means that out of the box, you don't have to convince a bunch of different developers to support things. So when you are working in the constraints of, well, we have to operate over HTTP or we're modeling this specific domain, doing this means that you instantly have access to things like client code and syncing and all of that, stuff you'd otherwise have to implement yourself or convince others to do. And even more interesting is when we start considering the fact that traditionally we see HTTP as kind of like the application layer to a degree. HTTP is more and more like you can consider it as a transport layer, and there's all these people building application-specific things on top of it using different technologies. And where that's really cool is the idea that it's language agnostic. So almost every major programming language, like I personally am yet to work with one that doesn't have it, supports HTTP out of the box. And it's usually pretty easy to get started, and the semantics are well known. And along the same lines, there's legacy. So if you need to solve a particular problem, there's usually someone who's already done it one way, or there's tooling that let you do it. Things like reverse proxies, intelligent caches, all these things that you kind of tend to reinvent the wheel with new protocols that do a lot of stuff, HTTP usually has. And the other part of that is we're now in an ecosystem where, especially when you're building to run on like people's computers and phones, APIs are the back end to that. So rich internet applications being ones that kind of tend to run in the browser using Flash or JavaScript, and mobile applications on iPhone, Android, all the different kind of platforms. Most of them implement or use some form of API behind the scenes to handle all the business logic. So they'll do presentation stuff, but you can implement all your stuff behind the scenes and abstract it. And where that I think is interesting is this point of this shift where we kind of go cyclically in terms of you have the time where all the logic's implemented on the server, and then you have dumb front ends that only do presentation, and then we kind of moved a lot of logic to people's computers, which is a good idea. And now for certain things, we're kind of shifting it back a bit and going, well, okay, maybe it's a good idea if we do all the presentation stuff on the client again, so we're not rendering HTML server-side using web as an example, and we can have this kind of like nice, separate, easy to maintain abstraction. And more importantly, it was about this idea of the web as a whole. A lot of people tend to see the web specifically here, not the internet, as just HTML, CSS, and JavaScript. And that's kind of like, I'm sure all of you are aware, that's just not true. There's so much other stuff that's hidden there that you can talk to and communicate, whether it's automating your entire stack, like provisioning servers, or making phone calls using services like Twilio or face recognition. There's all these little pieces out there that we can connect together and use. And all that said and done, like, why should you build an API when a lot of the time you can just open source the code? And it honestly comes down to one simple thing. Open sourcing isn't always feasible. There's a variety of reasons where as much as we'd love to open source everything, and personally, like most code I write, I try to open source, it's not always possible, whether it's logistics. For instance, you're dealing with real-time data, that shipping that out to people consuming your thing may be hard, or they may have to purchase hardware. So an API is an alternative way for you to expose all of that data to everyone for free, and get around having to have kind of like all that upfront cost. Or licensing IP, like as much as I hate to admit it, I've worked in companies where like there is stuff that you just can't open source for licensing reason, not just business stuff, but actual approaches to problems, things that other people would use. And the other one is operational. Like working with things that involve a lot of data, it's just infeasible to, say, ship 600 gigs of data to go with your library, as awesome as your library is. From a more technical perspective, it kind of encourages using a simpler facade or interface to your code. Not always the case, but a good example of this is a service that used to exist called face.com. And face.com was a really simple proposition. You give it an image, it gives you back image like faces, recognizing that sort of stuff. So the idea being that it can be this really complex problem, and there are a bunch of open source ways of doing it, like OpenCV, but they gave a much smaller subset that solved the problem for a variety of users, which as a result means there's a lower barrier to entry for consumption. I'm sure anyone here who's worked with a language that is like, say, Ruby or that, where it's a dynamic language, but you still have compiled extensions, getting those working can be a nightmare. With HTTP, the only requirement you have is a HTTP client that works well and like access to the API. So with all of that said and done, there's the thing that continually gets me working with APIs is that so many people attempt to build APIs and they're not necessarily good. And it's honestly really hard building an API that people enjoy using and that solves a problem and works well. But it shouldn't be. There's a lot of really, really simple kind of like rules of thumb that lead to good API design. Things that like even the best APIs in the world, or not even necessarily the best, just ones that do a lot of things like Facebook and Google's entire suite and that sort of stuff, they still get little bits of it wrong that you want to kind of deal with this moment of intense joy with the developer, like, oh, wow, that solved my problem. That only took me 3 lines of code and it was easy. Or the intense pain points of, I've spent 6 hours debugging why this response returns a completely different value to another thing, despite the fact I know they're exactly the same. So what follows, essentially, is a set of like the core things I've found across every API I've worked with that when you follow these rules, they tend to make it a lot easier to build good APIs and things that developers will enjoy, you'll enjoy. And as a bonus, they're not hard to do. Like, they're pretty straightforward. They just require a little bit of thought up front and are easy to do. So the first and most important one is considering your structure. And when I say structure here, I refer to 2 things. One, what sort of data you're returning and how you're returning it. So the key part of that, and the first decision you'll probably make with any API when it gets to actually building it out, is how are you going to serialize things. So how are you going to convert this data in your code into something the user can use? And as a rule of thumb, 99% of the time, the answer is simple: XML or JSON. Both are like easily usable in pretty much every language out there. They have a lot of history and legacy, but they're also pretty easy to work with. That said, most of the time, you probably want JSON. The core reason being JSON's types map well to the native types in your language of choice, typically. Like most programming languages now support things like hashes in some form or some name, arrays, booleans, all those sort of like really primitives. So they're not writing like custom classes to everything or map with them, which is kind of the pain point of working with XML. That said, XML still has its use of really structural, well-designed data, and so you shouldn't just discount it because it can be a pain to work with. At the same time, it's important to think in the terms of primitives. So small, simpler objects that you can combine together and build big things. It's really tempting to go, well, I have this database table, I'm just going to dump everything into one JSON hash and like work with that. Or a good example is address data. It's really tempting just to throw like your address as a string and a dump of all the other information you keep. Doing that sounds great in theory and you're really opening up a lot of data. The downside of doing that is that you end up sending back a lot of data that when you want to change that in the future, you're going to have a world of pain. So by thinking in terms of smaller, better data structures, which is honestly one of the hardest problems you'll solve, it tends to make it easier to build better APIs. Likewise, and this is one big thing I encountered working with APIs, and I think the Foursquare API was the first one I ever came across that did it really well, is serialized versions based on context. So people aren't going to want all of your data all the time, and more importantly, you're not going to want to have to send it all the time. The reason being, for instance, if you do have a really complex thing like a user and getting access to some statistics that you want to send with that may be hard to compute, the user may only ever access them on a rare occasion. So the idea of serialized versions in this case, for instance, like you may have a full user object that you can get through one API endpoint, and then you'll have a compact version you use most of the time. My rule of thumb tends to be there, and I come from recently building mobile apps, but it still applies to web and everything like that. Compact objects are enough to kind of list and show a summary of everything. And full objects are the ones that, like, when you're viewing a profile page or something like that. And it's amazing how much kind of that simplifies things, because you may only have 4 or 5 fields on a user that you care about most of the time, but you still want to open up that other data so people can pull it out. Likewise, there's a bunch of kind of standards, like, the two main ones being HAL and collection plus JSON. They define kind of a very rough basic structure for your response body. And I encourage looking at them, and the key part here is they kind of formalize the idea of, well, how do we link resources together and how do we nest them in a response and that sort of stuff. And what that effectively means is when it comes time for someone to write your code, they don't have to write as much to unpack it and check errors and all that sort of stuff. And that leads us on to the next point, and this is the single biggest pain point across any API I've worked with in terms of hours lost, which is well-considered errors. And it's kind of this rule of thumb that when you're building something, you think of errors as they're mostly internal, or you need to work out how to communicate them. So like C, for instance, you have a mnemonic in the form of like a little, what's the word? A constant sort of thing reference for it, or most languages, or you have exceptions and that sort of stuff. And especially in APIs where you have this really big kind of abstraction, you've got to remember the golden rule of thumb that if errors aren't just for libraries, they've got to be for the developer. So what that means is when you're thinking about your errors and how you communicate them to people, it's incredibly important that you think of the person sitting there at a computer after 3 hours, hitting their head going, why is this not working? And solve that problem. Make it easy for them to go, okay, well, this is what's broken. This is how I fix it. But it's also still important that they can use it in their library. So the kind of rule of thumb for me that I tend to use that works really well is a unique error identifier, of course something where you can kind of look it up and work out what it is, and a human readable description. The readable description being the bit that when it happens, they look at it and go, oh, okay, that's cool. That's probably this line in my code that I can fix. So a good example here in terms of structure, and it's important to note that you still should use HTTP status codes, which I'll get to in a second. But using JSON as an example, you have an error name, which is something unique across the API. The name itself should convey a lot of information, as well as the description telling you pretty much what happened. And likewise there, string identifiers pretty much all the time are way, way better than numeric codes. The simple reason being they convey that extra little bit of information where at a glance you can tell, like bad request conveys a lot more information, or missing authentication token, than error 47. Like Facebook is horrible for that at times because they have these huge number of like integer error codes, and to know what it means, you've got to go to an API and to a wiki and look it up, and oh, they've deprecated that part of the wiki and it's no longer available. But that said, you should still use HTTP status codes for errors. They're there for a reason. If you're returning errors with HTTP 200, you're going to break a lot of things. Like, it's just not going to work as you expect. So you should use these codes. You should understand what the 400 range and the 500 range in HTTP status code mean. For those of you who haven't done much with it before, 400 typically means it's an error with the client. So like they've requested something that doesn't exist, or they've given bad data, and 500 is something server-side. And inside these ranges, there's this huge list of different error codes that mean something. And a lot of the time, those error codes alone can convey a lot of information. And when I was saying error codes bad before, like these are HTTP error codes that are standardized. So you're still going to need more to say, well, specifically this is wrong. But in things like building an API client, it really simplifies things. If your HTTP status code is 400 or 500, then you should probably fix things. And at the same time, a really common thing people screw up is you should serve the correct content type. How many APIs I've used where they have like a public directory, so Rails, you have like the 404.html and 500.html files, and their web server configuration is just like the fail-safe is, if you get an unknown error, render these files. If I'm requesting an API with JSON and I get a HTML file back, like not only does that break the whole HTTP content negotiation, but it's really, really infuriating. And it's a simple thing. You just make your web server configuration serve up like a really rough, even it doesn't have to convey as much information, error, that says, yeah, something's broken, you should contact us here and we'll help you fix it. And the error names and all that information is all well and good, but it's still really, really important to document them, and document them across two scopes. The whole API, so things like authentication errors, rate limiting, the stuff that you're going to hit no matter what endpoint you're on most of the time, should document what the error code is, what it means, and usually if there's something they can do to fix it, how they can fix it. And in specific things, if you're explaining how you can create a user profile, then you should also document, well, if you give bad usernames or you already take an email, this is the error you'll get, and this is what it means. It's important just because there is so much expected knowledge when you're dealing with something. Make it easier for people to look that up, just saves a lot of time and will make them a lot happier. Likewise, and this is the one thing that most APIs are kind of now starting to, and it's so great to see. You need to make your API easy to explore and experiment, because people will explore your API. They'll play around with it, they'll try and break things, like it's another system to kind of attempt to break. But you shouldn't discourage that, you should encourage it. You should make it easy for people to get started and like just, oh, what does this resource do? And follow a link and all that sort of stuff, because people are going to come up with different things you can do with your code and combine it in different ways. And it's that sort of stuff, yep.
I was going to say that encouraging people to play around with your API, I would say one of the best ways to do that is to make your API rest.
Well, that's coming up.
Excellent.
So,
Sorry to spoil it.
no problem. So the most important thing there is you've got to remember, you need to make your API simple enough that you can curl and wget it. The hardest part here is going to be things like authentication, but a developer sitting at a command line with curl or wget, or even the humble browser, we kind of underestimate how useful that is, are going to be able to explore it really quickly and work through it and discover things. And as a side note on that, I spent probably about 3 months of just kind of side time trying to find a tool that I really, for me, worked well at exploring APIs, and the one I ended up selling on is a thing called HTTP. It's a Python package. So for anyone who's working with APIs a lot, I encourage you to Google it. What makes it interesting is the command is modeled on like HTTP itself a little bit. So you're still using the method in the command line and all that sort of stuff, but it does a lot of nice things like syntax highlighting of headers and pretty formatting your JSON, things that they don't seem like much, but when you're doing this all day, every day for a year, they really do add up and make things nice. Next up, and this is kind of the one that whenever you're talking about APIs, people become very passionate about the correct approach to do it, and it's change is inevitable. You are going to have to change your API at some point. How you deal with that is a sign of a good API. And it's a lot easier to design for that from the start and to bolt it on. And where this becomes interesting is the question of what are you versioning in your API? You have data and you have semantics. Data being like you add a field, you remove a field, you change how things are structured. And then you have semantics in terms of, okay, well, this endpoint, when I send an image, it may do this, or it may do this, or if I do a certain sequence of actions, how they change things. And why that's important is we kind of join them together because it's easy to roll one versioning solution, but they have very different consequences in how you design things. Data is a lot easier for people to deal with traditionally because you're just changing like a couple of lines of code where it points to something, typically. Whereas if you're changing the semantics of how that works, a lot of things are going to break and have to change. And HTTP has really great ways in terms of content type for doing data that don't work as well for semantics. And so the typical two approaches here are header-based and path-based authentication, versioning. Path-based is a lot simpler to understand. In your path or URL at some point, you include a version identifier. Whether it's like v1.api.so-and-so or like api.example.com/1, the idea is all of your parts of your API are prefixed with some version identifier. And this is really useful for semantics-based stuff because it means it's a completely different resource. So when you change it and you bump the version, you're no longer dealing with this idea that the person is kind of like, well, if there's someone else hitting the same endpoint as before, it's going to be a completely different set of code. And it's a lot easier to deal with versus header-based, where you've then got to consider the case, well, what if they miss the content type header, or the content type header changes, or they don't even consider the response? Whereas header-based is a lot better for doing data stuff. The idea being that you can do custom content types that, say, inherit from JSON in terms of what you expect. And so just adding a new response type there and changing in your code how you serialize things is a lot simpler for versioning. And the key part there is, like, HTTP has that built in. It's a part of how the web works and how we expect everything to work, whether it's images or HTML pages or JavaScript. It's important you understand how HTTP content type negotiation works and how you can leverage that. And even more important for data stuff, a lot of the time, it's a good consideration, and I'll get to hypermedia in a bit, which kind of covers this, that you should design for change. So, for instance, your clients may not actually care if you add a field. It probably won't, it's very rare that adding a field will break an API, but removing is almost guaranteed. If someone's using that field, and they likely will when I was talking about exploring before, you're going to break things. So if you design it that your API deals with that, an example being for code in general is things like, who here is familiar with semantic versioning? Anyone? Cool. So for those of you not familiar with it, it's an idea of how you version numbers, version numbers. And part of it is, like, if you're removing functionality or breaking something, you should bump the version. But if you're just doing fixes and that sort of stuff that doesn't necessarily break existing clients, you may not have to. So for instance, if you're just adding new fields as you go in your API or adding new endpoints, you probably don't need to bump the version all the time. But if you're removing things or breaking the semantics, you are going to want to change the version number somehow. And it's really important out of all of that, you understand the best choice for you. There is no golden bullet to versioning. And it depends on what you do. I personally prefer path-based most of the time just because it's easier to kind of reason about. But at the same time, it feels less right when it's just data. Following on from that, like it's important you also learn and embrace HTTP. So you need to understand how it works under the hood because sure, an API is an abstraction on top of it, but that doesn't mean it's something you can ignore. You should know intimately how it works. And HTTP can be simple, but it can also be really hard. So this diagram here specifically, it's from a project called Web Machine, and I can't remember the original creator's name, but this is kind of like a decision diagram for a HTTP request. So given user input, these are all the different variations in response and error codes and that sort of stuff you can get. And there's a lot to it there, and you may only follow like one very short, straight path through it. But knowing how that works means that you can design a system that it has less surprises and it's easier to understand and reason about. And there's a lot of small pieces in that are key to how it works. And when I talked about tooling before, this is what I meant. Like, if you follow these rules and build for that, it's going to give you a lot of power, and you're not going to have to write your own custom caching thing. You can just use HTTP caching. So examples of these, like the three that most people are familiar with working with the web in general, status codes. So what those numeric ranges I talked about before mean, how they change, things like redirects and the 200 series. Methods. So not just get and post, which is pretty much what we traditionally use in the web browser, but put, patch, delete, head, all of those options, option being another one amusingly, knowing what they mean and semantically how they change how your API works are important. And content type negotiation, which you only really need to understand a little bit of it, but it's really useful, seeing how that affects things like caching and other parts of HTTP. And the other one, and I'm really guilty of this when I started building APIs, was that you should use headers for metadata. And when I say that, things about the response, not about the information in your response, if that makes sense. So if you're returning a paginated list, so you have 10 million items and you're only returning 100 at a time, it's a pretty good idea to actually include pagination offsets and links being really important to other pages in your headers, because the HTTP head method, for those not familiar with it, it's like get, but it doesn't return the body. So it's really cheap for people to go, well, I want to know how many items you have and how to get the last page or the most recent. Then they only have to load a really small subset of data. And there's a lot of other things like rate limiting and other bits of metadata about how your API works. So you should put in there. It makes more sense. Put it in the body of the data, just break things. And more importantly, like when it comes to caching, that's going to make caching really hard. And caching is kind of like the one that when I started building APIs, I was so relieved with. So as a show of hands, again, who here does web stuff or has done web stuff? Awesome, most of you. Caching in web pages can be really, really, really painful, right? Especially if you're dealing with users and all these variations. It's go, well, what if this bit changes and the other bit stays the same, and how do I expire that? You have an advantage with well-designed APIs that HTTP's built-in caching things, so the cache control header, e-tag expires, they're really, really simple, but if you design your API well, they work. And where that becomes really awesome is things like Varnish, which are incredibly efficient servers that implement these standards. They give you basically not free performance, but really easy ways to solve issues. Like you don't have to render the same list of 10,000 items every request. And understanding how that works and more importantly, what the gotchas are in that design lead to make it really easy to do it. And it's our tendency to reinvent what's already there. As a programmer, at least I know I'm guilty of that. By using what's there and that sort of stuff, you save time and it just behaves better. And it's also important to kind of have a look at things like Speedy and HTTP 2.0 and how they can affect your design, whether it's performance or semantics or anything like that. Next up, authentication/authorization. It's the one thing that like everything else is like great in theory needs to work with, but as soon as you hit auth, you kind of like your brain breaks and you either roll something custom as people tend to do again, or you use a stand and like it gives developers literal nightmares. Like your auth should be powerful, it should be easy to use, and it should be secure. Should consider things like, well, what if I give a user of my system they want to give another service access, like Twitter, for instance, like saying someone can access this part but not that part. That's all really hard problems to solve, and it's really hard to balance all three. And my experience there, especially when building open stuff, is you shouldn't reinvent the wheel. Use something that's out there that considers that. It may feel dirty, but at the same time, knowing that it's there and that they've actually thought through these problems is really important. And the key things here to understand and remember are, so the HTTP authorization header, which is a very bare bones approach, and it's used by a lot of stuff, but knowing there's a bunch of standard approaches built on top of that that you can use to build your API. And also the two kind of main contenders across everything that deal with, especially the case of giving another service access on behalf of the user, OAuth and OAuth 2. Like, look into them, understand how they work, and as much as you can, avoid developers having to write custom code to handle your auth, because you will, it will break. So one of my favorite stories in this regard is working with an API where their authentication was like this MD5 checksum, and the MD5 checksum took like the path and all the query and all the information you gave it and an API key, and then it had a timestamp, which sounds all right, except for the timestamp was plus or minus 5 minutes, accurate to, I think it was half a second or something like that. And so every time you requested, they had to do a linear search over like a couple hundred different MD5 checksums. Like, if someone's going to emulate your API, that's going to be a pain. And for developers, I could never remember, after I worked with that API for about a year daily, I could never remember how to do it. Keep it simple, keep it easy to understand, and using something standard also means that when they build a client, they can just drop something in. They're not going to have to write their own code. So with that, there's a couple of standard API design approaches. So you know kind of like the little fiddly bits now, but this is the big one. The idea of how do you structure API to pull data out of it. And traditionally, our approach to this has been RPC. So give them a way to call a method or a function on your server and return data. So JSON RPC and XML RPC. Really simple, really easy to start developing, really basic. Or SOAP, for instance. The irony of SOAP being that it makes you feel dirty using it. This whole kind of thing of using RPC, it sounds good in theory, and it's really simple and easy to work, and it maps it, but it doesn't understand the realities of you're building for HTTP. It's this completely different abstraction. It's not your programming language of choice. And you may be building it, and it's easy for you in JavaScript or Ruby, but someone else could be using Haskell or another language that has completely different semantics, and so having to box that in is going to be painful. And the core of this comes down to resource-based APIs. So the last 5 or so years, kind of this move towards things such as REST, and REST being the idea that you use resources or representational state of transfer, basically leveraging all of the stuff we've talked about before. So resources in terms of different paths and structures of representing kind of nested things, and all the power of HTTP to build it. And then how Rails, and I'm allowed to say this because I'm a Rails developer, no one else is, or we'll fight you, like taking Rails, taking REST and then making its own thing that actually doesn't really work how you think REST should. Or what's now being, the term being HATIOs, or hypermedia as the transfer engine of application state, I think it stands for. The only, always get that one wrong. HATIOs being this idea, so Roy Fielding, who wrote the original thesis that inspired Rails' REST design and coined the word REST, in fact, this idea of actually the web not just being about hypertext anymore, it's about hypermedia, different objects that are linked together and interact in that fashion. And the idea with hypermedia stuff more and more being like, you can write a generalized client that knows how to explore your API and that sort of stuff. So actually designing your API to be discoverable, not just for humans, but for computers as well. You don't have to have all this upfront knowledge about what all the endpoints are and what they mean. You know how to explore the API and enough general information to get started, and you go from there. And one of the interesting approaches of this is graph-based APIs. So Facebook are probably the biggest graph-based one most people interact with on a regular basis. Their idea of modeling your API in terms of a set of resources that are connected via edges. So your resource is a node and it has edges for things like friend and stuff like that. And it's conceptually a really simple idea. Like most programmers are familiar with graphs. You come across them all the time. Modeling your API on that and then doing it in a way that is actually fairly RESTful, or like using resources and that sort of stuff, it's actually a really nice design, and there's a lot of power of doing that.
Are there any examples of that?
Facebook is probably the biggest one and the easiest. They break it. I'll find I have a list of them, but not on me. If you email me or ping me afterwards, I'll bring you a couple of examples. But there are some on the smaller scale, and hypermedia especially is kind of built around this idea. that your API is kind of this graph, and you don't formalize that, but you build around the concept, that being the next point. So I'm going to speed up for the next couple. So documentation is critical. It's all well and good to build an amazing API that is functionally awesome and well designed and like great to work with, but if your documentation is horrible, no one's going to be able to use it. You need to thoroughly document data choices. Things like if you have a field in your API that has 5 options, actually tell the user those options. Sounds really silly, but how often I've used an API and they've just completely forgotten to say, well, this field is the plan type, and never said what the plan type means. You need to document what that is, or in what situations fields don't show up, and then document how it works. So it's really important that it's going to be a lot of effort, I'm not going to lie, but document how all of that works together. Amusingly, the best example of that these days are Stripe and other payment providers. They're getting really good at giving examples. There's a lot of automatic tooling around building these docs. I encourage you to understand it and look at it and see how it's improving, but at the same time, handwritten still wins, because your API is going to understand, your tools are going to understand what the API looks like, but they're never going to understand why you made those decisions. So you need to still write the reasoning behind that so people can build it. And another really useful one for people using your API, make the examples language agnostic. Whether that's you write your API response examples as a cut down version of HTTP, so GitHub flavored Markdown being an example of a tool that it integrates code highlighting into Markdown, so you can just kind of like paste in a HTTP response and it will highlight all the relevant bits. Or you can actually go and do things like Stripe and Pin Here in Perth and a bunch of other companies are doing, where they have their own official client library, and those libraries give examples of, in this language, this is how you do this thing. With that said as well, when you're building your API and consuming, you need to choose your tooling wisely. You want tools to simplify, but not to completely abstract it away. So you need to understand HTTP still. Anything that removes that from you is going to mean you're building something completely abstracted that doesn't know the realities of everyone consuming it. You should build for the web and not for your language of your choice. So you're not building so it works for other Ruby developers traditionally, or other JavaScript developers, or other Go developers. You're building it for everyone. And by building for the lowest common denominator, HTTP and the web, you're going to get a lot of power. And yeah, you should still be caring and dealing with HTTP. It's just part of life, and you've got to deal with that, and it's actually nicer than it sounds. And the one thing that, like, all the bad APIs I've used, it's had one thing in common. No one who's built it has used it. Like, it sounds really simple, but using your API means you come across all the little things like, oh, that data structure sounds really great in theory, but actually using it, it's horrible. By using your own API, you'll come across these. Build hacks on it. Like, if you're doing an API that does music stuff, make a music player with it, or stuff along those lines. And all the little annoyances that you don't think about or just don't come to mind that will annoy other people building on it will crop up. And good APIs aren't just designed for computers, because great APIs are designed for humans. Like, you're not building your API for the client they're writing. That's kind of naive to think that. You're building your API for the person sitting there writing the code to use it, because they can make the computer do whatever they want. So you should optimize to the hardest part, which is making them happy and removing their sadness. So the final bit of my talk is, with all of that said and done, how do we actually embrace building open APIs? So I'm encouraging people to make things that are fairly easy to work with and fairly standard, and that you can say the S3 API was an example of one where people kind of picked up and ran with it, actually building from the start with the concept of, hey, well, what if other people implemented that API? App.net as a social network is a good example where their API is one that's designed to kind of work and if other people implement it. And the rules of this are pretty simple. You don't build yet another completely custom take on things, as our tendency is to do, authentication and authorization being the good example there, because then that means they're going to have to copy your version, not a standard way. You should emphasize simplicity. So take all the little bits you've learned and build primitives. Sure, it may not perform as well initially, but over time you'll learn the usage patterns with that, and it's a lot easier to go and use those really simple primitives than it is to kind of clone this whole thing that does a lot of other side effects. Use standardized and documented structures, so in your documentation, be upfront. Give a page that lists examples in JSON of every data type you return and how they vary. And kind of the counterpoint to that is expose as much data as feasible early on. Don't just throw it into one object, but make it possible for users to pull out all of their information. The whole argument about a walled garden in social networks where you can kind of lock people in. If you let people pull data out via the API, you may not be the one building the tool, but other people will. using standardized solutions I've already thought. Think of it as an interface, not a mirror of your own implementation. Don't design your API just to expose some code. Design your API and then implement it using code. And encourage people to build diverse implementations if that's your thing. And finally, most importantly, solve a real problem. Don't solve something that you perceive to be a problem. The best APIs come out of things like face.com, where it's something that's hard to do and you're giving people an easier way to do it, or things that just aren't possible. OpenStack and Amazon, all those sort of things. Like, without an API, they would be a lot harder. You'd be calling up someone and going, hey, can you create a server for me? Like, I'll only need it for 15 minutes, maybe half an hour. So if you solve something real, people will use it, even if your API is bad. And the best thing you can do is make it easy for them. So, questions? Oh, yeah.
I'm wondering about the trade-off between writing a nice API and writing an API that developers will expect. So take any domain, there's probably already a leading provider in that domain, say Facebook, social networking. So even though that API might be terrible, is there any benefit in modeling yours on theirs? Because that's what people will expect.
Yep. So the question for the cameras is there any benefit in terms of building a nice, clean API, if I understood it correctly, versus using an existing one that may be horrible, but users expect that? Or what's the right approach? And so my response there typically is it depends. A bit of a cop-out, I know, but things like Facebook are a good example because they're really powerful, but you're probably going to implement a subset of it. If your service matches up exactly and it's pretty straightforward, you do get that added benefit of a lot of tools that work with it and that sort of stuff. But if the tools don't let you do it, like they're designed specifically for Facebook, that benefit is completely null and void. So I think it's a balancing game. If it's something relatively simple and there are tools that are designed with that in mind, definitely use their design or at least make it similar. But at the same time, if you're able to build a clean, simpler interface and that benefit doesn't outweigh that, then definitely go that approach because it means you're dealing with, I guess, a lot less legacy, which is the key part. So, yeah.
Just wondering if you've had a look at JSON API.org's specifications for
Yep.
API design.
Yeah. So to repeat the question, it's if I've had a look at JSON API. And I knew that was the one I'd forgotten. So I have, and JSON API is actually, it's probably the newest option out of all of the ones like collection plus JSON and HAL. And it's, I'm trying to think of the right way to describe it. It's a really simple way of doing all of that stuff. And in fact, it's the one that I would suggest looking at. So short answer is I have looked at it and I really liked how you do it. I disagree with some of the points, but I think JSON API out of all of the options out there is awesome and it's something that people should be encouraged to follow. And so what makes JSON API different to a bunch of others is it has a little bit of other formalization about like response packaging, or packing rather. So like what do you nest things under and that sort of stuff.
Yeah, link entities and
yeah,
how you
like,
can optionally include related objects.
Awesome. So yeah, just a lot of the conventions around APIs and formalizing them. Yeah, so I'll add that to the slides when I post it as well as a side note for anyone after fact. Cool. Any more questions?
Do you have any advice as consuming an API for instances where the data that's coming back feels non-standard or even buggy, but doing some exploration as to where or how that's supposed to operate or what the documentation is? I have an instance where that's happening and I don't have any way or that I know of to actually find out how it's documented. It's quite frustrating, so I feel like I'm working around the bugs in my code, but I'd like to be communicating them back.
Yep.
How do you establish that communication if it doesn't seem well documented?
Okay, so the question there is there kind of any process or way of, if you're dealing with API and the data feels incomplete or buggy or just wrong, how do you communicate that to developers? My experience usually has been the companies that deal with APIs a lot, RDO is a good example, have a mailing list that you can communicate with. And if it's really bad and it's actually affecting your way, I've had a few where I've just gone around and like sort out developers, whether on GitHub or that way. And the whole like you apologize for contacting them, but at the same time, like if they know the person to contact you, maybe not ask the question directly, but if they know the person you talk to about API stuff. And the counterpoint of that is if you're building APIs, actually give developers a way to ask you questions. Yeah.
Just a sub-question.
Yep.
I don't know who the developers were because I believe they were contracted by a big entity who doesn't understand the technology. And I'm reasonably sure developers have either left or they're not around. I don't know
Okay, so the follow-up being, yeah, pretty sure in this scenario you can't actually contact the developers. In that case, yeah, it's the best you can probably do is keep track of it. So there's a bunch of tools like Apiary is an API middleman service, and it's mainly built for the people building the docs, but they have a feature that's like an API debugger basically. So it acts as a reverse proxy between the API and your tool, and it lets you keep diffs over the expected data for endpoints. Apiary, A-P-I-A-R-Y. And I'll include a link to that with the slides. But yeah, just keeping track of what's changing is probably a good start there. So yeah, no problem.
Do you have a favourite authentication method that would work from the console that you get in curl that isn't sending all the stuff in clear text like executable basic?
Okay, so the question is, do I have a favourite authentication method that isn't sending everything in plain text? Typically OAuth 2. The reason being OAuth 2 has added these extra flows that let you generate API keys. Or not API key, what functions like API keys, so you can pass it through as a query token parameter. So the initial act of getting that key to explore the API is harder than, say, if it's just an API token in HTTP basic, but being able to explore with that is a lot easier because once you've got it, you can just go through it. And to deal with the plain text aspect, so the security aspect of it, in theory, if the authentication in the API is like that, you should just be serving it over HTTPS. Most of the benefits of using non-plain text stuff will be solved, things like replay attacks and that all the other kind of more advanced add-ons to OAuth 2 do. And pretty much every other authentication system you're going to design can be kind of avoided within a reasonable degree of usefulness with running it over HTTPS, and it's not that much more expensive. Matt?
Can you just comment briefly on maybe a point you made earlier of some of the dangers of relying on external APIs? Perhaps the developers are available for contact or maintenance or support. You mentioned face.com isn't available anymore, but it's being utilised in applications and that. So what are some of the dangers and hazards to consider when effectively outsourcing responsibility to API?
So Matt's question is, what are the dangers essentially with outsourcing things to the API in terms of if it goes away or changes? And how do you counter that? So the Face example Matt gave is really good. So face.com were acquired by Facebook, and so their API shut down. So instantly you have all these people who've built on this platform which is useful and it's gone away. The twofold part of that is when you're building the API, you should be accounting for that or designing your system. If your core part of your product is building off another API, it's important to understand that that can go away. It's completely out of your control. So you should have that in mind when you're designing the system, which is harder than it's harder than it is saying, or harder to do that rather. So it's kind of a cop-out, but keeping that in mind makes it a lot easier for you to switch it out. And also know the options. If you do have to build it yourself later on at time, and you're just deferring the option for now, know how you're going to do that, or at least have a battle plan. Yeah, and I think I'm there.
Intermingling HTML dynamically generated content with your API? Do you put it in? Do you have a separate at the top level? Do you have a separate tree entirely for it, or do you have separate modules in your kind of site? Do you put it under each module separately intermingled with the HTML?
Just before I answer, can I ask a clarification on one part there? Do you mean the HTML in terms of the web pages users are using, or as a... Okay, so the question is, do I have any thoughts on basically the same code sort of thing or same application serving HTML and JavaScript, and how do you structure that? My typical approach is to actually separate them out. So you have the API under a complete separate, different set of endpoints. The reason just primarily being the semantics are different completely. Like with HTTP, it may redirect to another resource and do that sort of stuff, or it may expect different fields or different structure. There is power definitely to using it in the same namespace in terms of URLs. But that power can be kind of painful because of content negotiation, and there's just a lot of different variants to remember around that, if that makes sense at all. So my personal preference is to avoid it completely and have separate stuff, but be aware it can be useful. Yep.
So it sounds like you prefer sort of multiple smaller primitives that are linked together rather than like very large resources. How would you counter arguments that by doing that you require multiple steps to achieve anything useful?
Yep. So the question is, basically, I'm arguing for the idea of smaller primitives that you combine, and there's the counterpoint to that is doing so requires more steps to achieve something useful. And the point of that becomes that for a start, building primitives, it may take more steps, but it's a lot easier to evolve. And once you implement something, it's hard to take it back because people are using something outside of your control. So just start simple, and then as you see those use cases, you can actually abstract it and use those things. So kind of build them as they come up. Cool. I think that's all I have time for.